Alright, so 1.7, and this is called the logistic equation. Logistic equation. And we'll write it again. So the logistic equation is y prime equals ay minus by squared. So it's not a linear first order differential equation. It's not linear. Not linear because of y squared. It's only not linear with respect to y. Right, we're only talking about linear y. Yes. So we're going to just study the differential equation for a bit, and then we'll solve it. So in order to do that, we're going to do this. I'm going to write it another way too. I'm going to write this as y prime, which is equal. I'm just writing the equation ay minus by squared. We're also going to call it, we're just going to look at actually at the derivative itself and see what it tells us. So we're going to call this capital F. Notice this, F of y. Notice, we went to one. Notice F of y does not have a q of t term. Everything on the derivative is in terms of y. And when you have this case, we call that an autonomous differential equation. Since f of y is only dependent, is only dependent on y, not t. It is called autonomous differential equation. Now let's break D.
Is it on a process that we don't have a differential with Q of T right now, or is there going to be a y squared logistic equation? Or is there going to be an equation that has that y squared too, but also has a Q of T?
Eventually, no. It's still going to be autonomous. That's we will introduce a constant. We will introduce a constant. You'll see as we go. But what we're starting with is an autonomous. that is an atomic state. If it had something else, then it's not, and it's solution. So right now, this is all we're looking at. But the answer is yes, we will look at when it's not autonomous. But then there'll be some other form, some other key. But right now, we're going to start with that. And, oh. Recall this. Let's see, the steady state. The steady state is when f of y equals zero. Now, you may have been thinking, wait, how did I know that? And I'm going to show you, you actually have seen that in some of your homework. It would ask for, the problem asks for y infinity. And now you can go and you can solve the whole problem and finally you get an answer. Or you could have just started with the original equation and found the solution just as easily, and I will show you that in a moment. So remember when you're talking about this logistic equation, when I talk about f of y, it's this right-hand side, you always want to keep in mind that this is a derivative that we're looking at. So when the slope of your solution is 0, is when it's unchanging, is when at that point you have a horizontal line. So remember that that's a derivative, not a function like you're expecting. We're just looking at derivative. So, for example, so let's do this for example. If I was to give you the problem of y prime plus 2y equals 6, and I said find the steady state. Find steady state. What did we call the steady state? We're calling it y infinity. What happens in the long run as over time? And what had always happened is when a was less than 0, you'd have all these terms. When a is less than 0, the e to the minus at terms go to 0. We're left with q over n. So in this problem, q is what? 6. A is 2, and so the steady state was 3. So here, q over a, and this one would be 6, 2, which was 3. But there's another way to do that, and that's this. Or you could have said that y prime is equal to minus 2y plus 6. And the steady state is when this equals 0. If you solve that, what is the steady state? 3. Yeah, that's it.
So, avoid confusion, or maybe I'll start confusion. Isn't it negative q over a because a is negative?
It depends on where you put the
So like
2y
in this,
term.
equation, a is negative 2.
It becomes, so right, a becomes negative 2
Because you're dealing with y prime minus a y.
You can just solve it. If we do,
Or you just bring it to the other side, if the
Yeah.
differential equation is y prime
Right.
equal to minus 2y plus 6.
you get, so A is, let's put -2. You're gonna come up with this. On the right-hand side, and that's where you're going to pick up your positive Q over it. So it is gonna work out. You're right, A is negative, but when you multiply it out, in the end, the result is. So I guess I should have put,
It's negative q over a.
there we go. Good. You're right. Okay. So let's do the same thing here. Let's do the same thing. So let's set f of y